In March 2026, NASA introduced an ambitious new strategy for the future of American space exploration. On the surface, it appears to be a plan for building a long-term presence on the moon, which is remarkable. But the more important revelation is that NASA itself has fundamentally transformed into something the world has not witnessed in decades. And the reason behind this shift goes far beyond new leadership. A major power competition is set to unfold on the moon throughout the next decade. The previous version of NASA was not prepared to win that race, but the new NASA is determined to compete at the highest level, and this is how they plan to accomplish it. When Administrator Jared Isaacman stood on the stage at NASA headquarters in Washington, D.C., one simple word appeared on the screen behind him: ignition. That word signaled the beginning of a transformational chapter for the American space program. The old status quo has been abandoned and replaced with a new direction focused on setting high expectations and delivering results. Isaacman admitted that for decades NASA had been stretched too thin. The agency tried to satisfy too many interests and, as a result, achieved far less than it should have. The outcome was billions of taxpayer dollars spent inefficiently and valuable years of progress lost. He also explained why this transition must begin immediately, because more is at risk than simply money and time. There is now a growing competition with China to establish the first permanent presence on the moon, and this challenge is very different from the space race of the 1960s. This time, the objective is not just flags and footprints. This time, the objective is permanence. America does not intend to leave the moon again. Now, these kind of promises have been heard before from NASA administrators and political leaders over the years. But statements alone mean very little. Without action, and historic progress requires intelligent planning, which has been one of the major weaknesses of the Artemis Moon program from the start. Still, better late than never. A detailed and achievable step-by-step blueprint for the Artemis Moon Base has finally been introduced, and it begins with a complete restructuring of the moon landing schedule as we currently know it. The first major change is that Artemis 3 will no longer place astronauts on the moon. Instead, it has been redesigned into a full dress rehearsal mission that will take place in low Earth orbit. At first, this may sound contradictory to everything discussed so far, but in reality, it makes far more sense because the previous plan attempted to jump from Artemis 2, which is simply a crewed test flight of the Orion spacecraft, directly to a lunar landing using a completely separate and unproven HLS vehicle. That goal was unrealistic, and the level of risk was so high that the mission would likely never have succeeded. As a result, the launch date continued to move further into the future year after year. Under the updated strategy, Artemis 3 will instead involve the crewed Orion spacecraft meeting the lunar lander in low Earth orbit for a rendezvous and docking operation. The astronauts will then transfer into the lander to test its life support, communications, and propulsion systems. If conditions allow, they will also test the new lunar EVA spacesuits inside the lander airlock for the first time. Conducting these operations in low Earth orbit means that technical issues can be resolved and astronaut safety can be protected if anything fails to perform as expected. The Orion spacecraft is already well understood, but the lunar lander remains a major uncertainty. For years, most people assumed this vehicle would be a lunar version of the SpaceX Starship, but that is no longer guaranteed. Isaacman has confirmed that Blue Origin has officially re-entered the competition alongside SpaceX with its Blue Moon lander, and one or both of these vehicles may participate in Artemis 3. Everything now depends on which company can deliver a working system on time. This represents a major shift in NASA's new direction. Even SpaceX is no longer guaranteed a moon landing contract. Winning a contract in 2022 is no longer enough. What matters now is performance and execution. The first company capable of achieving the mission objectives will be the one that returns American astronauts to the moon. The deadline for Artemis 3 has now been moved forward to 2027. After the lunar lander is selected, the winning company will be expected to move forward at an extremely rapid pace. They will have only a short period of time to complete an uncrewed lunar landing test before preparing a finalized design for Artemis 4. That mission is currently scheduled for early 2028. This is expected to mark America's return to the moon with a landing near the South Pole region. But as Isaac Mann emphasized, this mission is not simply about flags and footprints. To demonstrate that commitment clearly to the world, NASA plans to return astronauts to the moon again in 2028, with Artemis 5 scheduled before the end of the same year. That timeline may sound extremely ambitious, but it reflects the way NASA operated during its golden era. The time between the Apollo 11 landing and the Apollo 12 landing was only 120 days. And this is not simply about proving a point. It is designed to establish a new rhythm for American lunar missions, with crews arriving on the moon approximately every 6 months moving forward. This is also the stage where NASA's focus shifts toward building a permanent human outpost on the moon, and that process begins by placing surface operations above everything else. So the Lunar Gateway space station that was originally planned to orbit the moon is no longer part of the mission plan. However, that does not mean the time, money, and resources invested in Gateway have been wasted. Much of the hardware already developed for the station is now being repurposed for the construction of the first lunar base. The building of that base will take place over the next 7 years, and NASA has committed a budget of $20 billion to complete the project. The entire program is divided into 3 phases, and the first phase begins immediately. Phase 1 covers the years from 2026 to 2028. The main objective during this period is to establish reliable access to the surface of the moon while maintaining a high launch frequency. That means carrying out 25 missions in the first 3 years, including 21 lunar landings. 2 of those missions will involve crewed operations, but most of this phase focuses on testing technologies needed for future moon base activities. One major area of development is nuclear power on the moon. There's a major sunlight challenge on the lunar surface that must be solved, and nuclear energy currently appears to be the most effective solution. The moon's day and night cycle is much longer than what we experience on Earth. As a result, the Artemis base will go through nearly 2 weeks of continuous sunlight, followed by another 2 weeks of complete darkness. During that dark period, temperatures can fall below minus 200 degrees Celsius. Without a reliable heat source, much of the equipment on the moon would freeze solid. That creates serious problems for electronics, which often cannot restart properly once temperatures rise again. To address this issue, NASA plans to experiment with radioisotope thermal generators. In simple terms, these systems use radioactive materials, such as plutonium. As a material naturally decays, it releases heat, and that heat can then be used to prevent lunar equipment from freezing during the long lunar night. So what kind of equipment are we talking about? NASA is developing a new concept for exploring the moon known as moonfall. These are rocket-powered drones inspired by the Ingenuity helicopter used on Mars. Instead of propellers, however, these vehicles use small rocket thrusters for movement. Each drone can remain airborne for about 150 seconds during a single hop and travel distances of up to 50 kilometers. NASA plans to use them to explore dangerous and difficult areas such as mountaintops and the edges of deep craters. During Phase 1, NASA will also deploy the Viper rover. This golf cart-sized vehicle has already been built and tested and has spent years waiting for transport to the moon. According to the current timeline, 2027 will finally be its launch year. Viper will reach the lunar surface using a Blue Origin lander. Once deployed, it will begin mapping the South Pole region to confirm the presence of water ice and other valuable materials, including hydrogen, oxygen, and rare earth elements. NASA refers to this process as lunar prospecting. Identifying the location of these resources will become extremely important when the program reaches Phase 3. Viper will also be joined by 2 lunar terrain vehicles. One rover will be operated directly by astronaut crews, while the other will function autonomously. Each vehicle will be capable of covering up to 900 kilometers across the lunar surface. In addition to exploration, these rovers will also perform construction tasks such as transporting equipment, leveling terrain, and preparing sites for future infrastructure. Above the moon, NASA also plans to place a new network of lunar communication and observation satellites. These systems will allow continuous data transmission between the moon and Earth, with speeds reaching 500 megabytes per second. The satellites will also provide a constant orbital view of the entire lunar surface. This part is especially important for the public because NASA has confirmed that all of these vehicles, including the drones, rovers, and electric transport systems, will be equipped with high-quality cameras. Their missions will be live-streamed back to Earth for people around the world to watch in real time. That leads directly into Phase 2, which focuses on the beginning of lunar base construction. This stage will run from 2029 through 2032. It includes 27 launches and 24 lunar landings, along with the delivery of the first infrastructure designed for permanent habitation modules. During this period, NASA plans to deploy 6 additional rovers that go far beyond simple exploration. The agency is now discussing excavation operations during this phase. These machines will be capable of moving rocks, leveling terrain, and digging trenches for power systems and pipelines. The goal is to prepare the foundation for long-term lunar development. One of these new vehicles will become the first pressurized mobile habitat on the moon. It is currently being developed by the Japanese Space Agency in partnership with Toda. This 15,000-kilogram vehicle will essentially function as a mobile living space. Astronauts inside will be able to live comfortably in regular clothing while traveling across the lunar surface at speeds of approximately 3.5 kilometers per hour for extended periods of time. The rover is expected to have an operational lifespan of around 10 years and will be capable of functioning for up to 150 hours in total darkness. Phase 2 will also require more energy than any previous stage of the program, and NASA plans to meet that demand through 2 primary power systems. The first source will be solar energy. Large solar panels will be installed on top of tall structures to capture the maximum amount of sunlight possible. These systems will then be connected to large-scale battery storage units for long-term energy retention. That system will also be supported by nuclear power, and this goes far beyond simply keeping equipment warm during the lunar night. NASA plans to deploy nuclear fission reactors on the moon capable of generating hundreds of watts of electricity while powering multiple systems at the same time. By the end of Phase 2, the necessary infrastructure will be in place to support humans living on the moon for extended periods. Then comes Phase 3, which is when permanent habitation truly begins. This phase covers a period from 2033 and beyond, and the main objective will be the continuous occupation of the Artemis Moon Base. NASA believes it will be possible to maintain a rotating crew of 4 people, living on the moon for missions lasting up to 28 days at a time. The astronauts will live inside several connected habitat modules, essentially a space station similar to the ISS or the original Gateway concept, except built directly on the lunar surface. These habitat systems will be powered by dedicated nuclear fission generators and will receive approximately 8,000 kilograms of food, water, and breathable air every month. Outside the base, NASA plans to begin its first major efforts in situ resource utilization. That means collecting materials directly from the lunar environment and using them to support operations on the moon. Water will be extracted from ice deposits located inside permanently shadow craters. That water can then be separated into oxygen for breathing and hydrogen for fuel production. NASA also intends to begin testing advanced 3D printing systems using dust and soil from the lunar surface. The agency plans to melt these materials into a form of pourable cement that could eventually be used to build the first truly permanent structures on the moon. Now, if all of this sounds almost impossible, that reaction is completely understandable. NASA itself has acknowledged that these goals are extremely difficult and push the limits of what is currently possible, but that is exactly the purpose behind the mission. The objective is not to pursue something easy, but to accomplish something challenging. China is also preparing to achieve difficult and highly ambitious goals. That is the reality of the new space race. Simply being good enough is no longer sufficient, and NASA now understands something it had lost sight of for many years, because the true purpose of the Artemis program is not only to build a moon base. The larger goal is to inspire a new generation of scientists, engineers, and explorers. These are the young people who may one day achieve things that seem impossible to us today, but future generations cannot accomplish those goals without the motivation to pursue them in the first place. NASA's responsibility is to lead through action and example, and for a long time the agency had not fully done that. But according to this new direction, the future of American space exploration is finally moving forward again. And if you want to explore what NASA's future lunar city could look like beyond Phase 3 of the Artemis program, click the box on your screen right now